Hi guys! Today we're going to continue talking about organic chemistry, and remember, organic hydrocarbons are compounds that have just carbons and hydrogens. Organic chemistry is compounds that have carbons and hydrogens and other things, organic compounds. Alkenes and alkynes are more of the homologous series that we talked about. A homologous series is a group of compounds that have similar properties because they have the same types of bonds. Alkenes have a double bond. Alkynes have a triple bond. Okay, and so let's go on. So here is an alkene. Why is it an alkene? Because it has one double bond. Okay. Hydrocarbons containing double bonds are alkenes. The general formula is carbon, however many carbon is, the hydrogen is times 2. So if there's 5 carbons, the hydrogens would be 10. They are unsaturated. Why unsaturated? Because the double bond is a space where reactions can happen, and it's when carbons are all single bonds, there's no place for a reaction to happen, and they're pretty much alkanes are pretty much very unreactive. You can get them to react, but they're very unreactive because there's no double bond to break open and add something. Okay, they are unsaturated. The double bond is a reactive site for other atoms to bond to the carbon atom. Alkenes, the names are, we talked about these: eth, prop, but, pent, hex, hept, oct, non, and dec. And so you just add the ene ending. Instead of ethane for an alkane, it's ene for an alkene. So naming them. How do I name these guys? I first have to find the parent chain, but the parent chain has to have the double bond, even if it's not the longest chain. And this is different from alkanes, right? In alkanes, it was the longest chain regardless. In this case, in the case of alkenes and alkynes, you have to have the longest chain that has the double, or in the case of alkynes, triple bond. So this is going to be, the longest chain is not going to be 1, 2, 3, 4, 5, 6 hex. It's going to be 1, 2, 3, 4, 5. Okay? So the parent, and I'm going to start numbering at the closest end to the double bond. So here's a carbon. So I have to start numbering on this side. I can't start numbering on this side because this side is the side closer to the double bond. So it's 1, 2, 3, 4, 5. And the double bond is on the first carbon, so I say 1 pentene. Okay. So that's the name of the chain. But now I have a substituent, right, on the second carbon. So how am I going to do that? So on the second carbon, there's an ethyl. Why ethyl, Ms. Osman? Because it has 2 carbons. So it's the 1 pentene is the chain. Okay, and then on the second carbon, there's an ethyl. So I say 2 ethyl, 1 pentene. Okay, so the rules are name the parent chain, number the parent chain, name the branches, name the compound. So this what's this going to be? This is going to be 1, 2, 3, 4, 5, 6. This is going to be what? 2 hexene. And there's no branches, no substituents, so just 2 hexene. How about this one? 1, 2, 3, 4, 5. Oh, it has 2 double bonds. What do I do now? Miss Osman, what do I do now? It has 2 double bonds. I just say I have 2 double bonds. On the first carbon, I have a double bond. And on the third carbon, I have another double bond. So 1, 3, penta. Penta is the chain. How many double bonds do I have? 2. So di-ene. So 1, 3, dash penta diene. Okay? That's kind of funky, right? I haven't seen that before. But it's not that hard, is it? Why not? 1, 2, 3, 4, 5. Why not 2, 3, not 2, 4? Because I always have to go with the lowest numbers. Alkanes. Alkanes are the same. The rules are pretty much exactly the same as alkenes. The only difference is the general formula is whatever the carbon is, the hydrogen is times 2, and then you subtract 2. But then again, you always have to find the longest chain that has the triple bond in it, and you have to number from the side that's closest to the triple bond. Okay, the rules are the same. But you say ein instead of een. So ethyne, propyne, butine. So how would I name this? It's going to be 1, 2, 3, 4, 5. It's going to be pentyne. 1 pentyne. Why 1? Because the triple bond is next to the carbon. 1, 2, 3. On the third carbon, there's a methyl. So 3 methyl, 1 pentyne. How about this? Where's the longest chain that has the triple bond in it? 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's going to be across and down and around. So this is hexyne. So my guess it's going to be 1 hexyne. Is that a good guess, Miss Osmond? Yeah, it's a good guess. Yeah, Miss Osmond, that's a good guess. 1 hexyne. And then on the 1, 2, 3 carbon, I have a ethyl. And on the 1, 2, 3, 4 carbon, I have a methyl. So what are we going to do with that? Why did I put the 3 ethyl before the 4 methyl? Remember, these are put in alphabetical order. E comes before M, so that's why I put it in this order. Next slide. No, next slide. Are we done?